Please welcome our guest, Colin Hill. He has a Ph.D. in molecular microbiology and is professor in the School of Microbiology at University College Cork in Ireland. After a warm welcome, I asked a question about microbiology as a science.
Yeah, that's a big question. I mean, microbiology obviously has always been part of our world. It's a microbial world. We live in a microbial world. All of the oxygen that we breathe was created by microbes. The earth just simply, there's a famous saying, the earth or the moon is the earth without microbes. So microbes created the world we live in, and they occupy every niche on earth. And so we evolved into this microbial world, and we are covered with microbes internally and externally. That's our microbiomes. And all of the food that we gather when it's in its raw state all has microbes on it. And microbes, of course, can attack our food. They can attack us and cause diseases, COVID and many other diseases. But they can also cause food to spoil, of course. And we're all familiar with molds and things going off when you're trying to store them. So as you said yourself earlier, thousands of years ago, people discovered that you could kind of manipulate raw materials like flour and water to become more resistant to being spoiled. You could ferment them. And so fermentation became a huge weapon in human beings' arsenal, and has helped us to become civilized people, because we were able to gather food and keep it for longer, because we didn't have to gather food every day. We had more time, and because we had more time, we could do more things and develop. So microbes are absolutely essential to all human activity and to all activity on the planet. But as a science, it's a relatively young field of a couple of hundred years. That was when people first started to ask the question, what is happening when something ferments? What is happening when somebody becomes ill with an infection and dies? And identified these tiny little microbes that usually were found in this negative way. They're spoiling our foods, they're causing disease. And so for many people, bacteria, microbes have a negative connotation, because that's they're dirty. If there are microbes on something, it's dirty. But of course, that's not the case. There are microbes on everything. And so the science of microbiology was developed by simply looking through microscopes and seeing them. And then, of course, we became better at characterizing them. And then we could eventually reach a point today where we can sequence their genomes and understand them, and understand them probably better than anything else. And most basic biology is done on things like microbes, because of course there's no ethics. No one cares if you kill a lot of microbes to learn something about science. And they're very quick to grow, and you can grow a lot of them very fast. And so again, modern science depends heavily on microbiology, on using microbes as a way of understanding life on Earth. So it's a fairly new science, but an incredibly important part of the world that we live in. I am a microbiologist. I'm a professor of microbiology here in University College Cork in Ireland. I trained, in university as a biochemist actually, and then switched to becoming a microbiologist, and have spent my career, 30 years, doing research in microbiology, working with industry on microbiology related projects, but also working on basic problems in microbiology, but almost always on the microbes that interact with the human body. So bacteria that cause disease, or bacteria that make us more healthy, like probiotics, or the microbiome, the bacteria that live in and on the human body. So that's my kind of area, rather than there's people who work on the role of microbes in the environment, or the role of microbes in various different places. My main area is microbes and health. We call it a virtual organ, because it's an organ that you're born without. When you're born, you're essentially sterile. You have no microbes at all. And then you get microbes from your mother as you're being born. And in fact, if you're born by cesarean section, you get microbes mainly from the staff in the delivery room rather than from your mother, which is kind of a strange start. And then your mother gives you mother's milk, and mother's milk contains sugars that the baby simply cannot digest. So they're of no value to the baby at all. But the microbes within the baby can digest these sugars. So we can see that evolution has created a situation where as you're born, you're given this organ, this virtual organ from your mother, and then your mother, one of the first things your mother does is feed this organ to make sure that it properly develops and that you get a good microbiome at the start of your life. Now, even if you were born by C-section and even if you're bottle fed, eventually, of course, your microbiome accumulates and becomes a positive force. It weighs about as much as your liver, so it's a big organ because the liver is your biggest organ, and it is more metabolically active than the liver, so it's a very important organ, and it communicates through our nervous system and our immune system with us. So most of our nervous system, actually, most of our nerve endings are in the gut facing inwards, not on our skin facing outwards. We normally think that we have, we can touch and feel things, so that's where our nerves are. But most of them are actually in our gut facing inwards. And our microbes can produce the kind of chemicals that our nerve endings respond to, like acetylcholine and serotonin and GABA and these chemicals. And so there's a huge communication between our gut, our microbiome, and our brain. In fact, one of our major nerves, the vagus nerve, connects our brain down to our gut. And many people will experience this, that if you get scared or nervous or frightened, that your stomach can start to churn, or a lot of us talk about gut feelings and gut, that we describe things through our gut feelings almost. And so, yes, there's a huge connection between our brain and our second brain or third brain, if you want to include the heart as well. Yeah, probiotics. Pro is obviously Latin for. Biotic usually means life, so probiotic is kind of for life, and it means that it's live bacteria, our yeast, so live microbes, that when you consume them, they give you a health benefit. So the definition of a probiotic is that it has to be alive when you consume it, and it must give you a health benefit, and that must be proven. It can't just be, I feel better when I do this. It must be actually proven in a proper trial with placebos and active groups and statistics and, clinic nutritionists and doctors involved. It must be proven very formally that, yes, when you take this bacterium or this yeast, there is a measurable health benefit. That's a probiotic. A prebiotic is anything that you eat that you cannot digest, but the microbes in your gut can digest. That leads to a health benefit. So fiber, for example, that is present in many foods, we can't really digest fiber, but the microbes in our gut can digest it, and they can then give us a health benefit by producing short-chain fatty acids and things that what we do need, and so they give us that health benefit. So probiotics are live microbes that you consume that give you a health benefit. Prebiotics are essentially food for the microbiome that gives you a health. Fermented foods are foods that are made through the action of microbes. So you sour milk to make yogurt, or you sour milk to make cheese, or you ferment barley to make beer. These are all fermentations. And what they are designed to do is what we were talking about earlier, to preserve the nutritive value of the food. So if you have fresh milk, you can't keep it very long, especially hundreds of years ago when there was no refrigeration, or you couldn't dry something into a powder, for example. And so what we did to protect the nutritive value of the food was we fermented it. And that meant you added bacteria, or you took advantage of the natural bacteria that were present in the milk, they would produce acid and make the milk go sour. And that sour milk would separate into curds and whey, and you could make cheese out of the curds, or you could make yogurt, and that could last much longer than the raw milk would last. So fermentation is almost all designed to protect the value of the food stock, to take a raw material, raw food, even meats, and turn them into fermented meats, fish and turn into fermented fish, vegetables and turn them into sourdough or sauerkraut and things like that. It's almost all about protecting the nutritional value of the raw food and keeping it for longer. So fermented foods, of course, then are usually full of microbes because microbes have grown in them. So you're using kind of good bacteria to prevent bad bacteria getting in. That's a bit of a simplification, but that kind of explains what you're trying to do with fermentation. No, because it doesn't have the second part of the definition of probiotic. The first part is it must contain live microbes, and it definitely has that, but it must have a proven health benefit in a properly conducted clinical trial. So a lot of people will say, you know, I never used to eat sauerkraut or cheese or yogurt or something, and now I eat it and I feel much better. That doesn't make something a probiotic. It may be real and somebody may be experiencing a health benefit, but unless it's proven, you can't formally call something a probiotic. So what we say is that fermented foods are, of course, good for you because they contain lots of ingredients and metabolites and things that are very good for you, but they don't fit the definition of probiotic. Some fermented foods are just digested by us. Some fermented foods will contain ingredients which the microbes haven't broken down, that maybe the microbes in your gut break down, but no, there's not a one-to-one link there. Right. Oh no, there's a lot of work. You see, the problem is you can see, for example, that if somebody never eats yogurt and then they start eating yogurt, their microbiomes might react to that and change a little bit, but we can't then necessarily say, and that is there for a health benefit, because you have to show that that change in the microbiome actually led to a health benefit. Now, we're looking actually at the evidence to see, can we prove that fermented foods are actually good for your health? Can we find statistically valid evidence for that? And we're doing some very big surveys together with colleagues in America and in Asia, but the evidence, we're not there yet. We're working our way through the data. We're working with, yeah, we're hoping to show that people who eat more fermented food have better health. But that's a hypothesis that we're going to try to prove, but we haven't got there yet. But that's the way science works. You find something that you believe or that you believe to be true, but then you must be very open to the fact that you're just as likely to be wrong as to be right. And so you must really rigorously try to prove it. You can't, science isn't a belief system, it's a proving system. Yes. And so you have to, as you said earlier, we're trying to get at the truth, but science is always done as a kind of conversation. I say, I think fermented foods are good for you. You say, well, I will therefore take the other side and say, I don't believe they're good. Now, how are we going to prove which one of us is right? Right. And so that's what we're trying to do. So I put it bad. We're not trying to prove that fermented foods are good for you. We're trying to find out if they are good for you. Your microbiome is unique to you. Your microbiome is very different from my microbiome. But if we looked at your microbiome today and looked at my microbiome today, and then came back in, say, a year or two and looked again, your microbiome would still look very similar to the way it looks now, and mine would still look very similar to the way it looks now. So what happens is as you grow, and usually by the time you're, a very, probably around 6, 7, 8 years of age, you've kind of acquired the microbiome you will have for most of your life. And it's quite difficult to change that microbiome. If you change your diet very dramatically over a long period of time, you will change your microbiome. But just changing, having a week where you eat burgers instead of vegetables, isn't going to have much of an impact on your microbiome. It's very resilient. It's, it's like if you drink a lot of alcohol, you will damage your liver, but just for a couple of days, and then your liver will recover. So you can do temporary damage, but really doing long-term damage, you'd have to drink alcohol, lots of alcohol day after day after day to really ruin your liver. And to really change your microbiome, you'd have to go on a very strange diet for a long time. So your microbiome is unique and it's resilient, very robust within you. It's very hard for another microbe to invade that microbiome. So when you eat kale and it's covered in microbes, most of those microbes will just go straight through. It would be very rare for one of those microbes to colonize you and become part of your microbiome. Now, when you were a baby or when you were very young and your microbiome wasn't very well developed, then the foods you're eating are contributing microbes towards what will become your microbiome. But once your microbiome is established, it's pretty established and it's very difficult to change it. So when you take probiotics, for example, these live bacteria that are good for your health, you have to take them every day or every second day because they just pass through. But they can have a health benefit while they're passing through. The bacteria that you eat that are on the kale just simply pass through.
Right.
The bacteria that are already in there, they will have, enzymes that allow them to break down foods that the human can't break down. So we might be able to use some parts of the kale and the bacteria will digest other parts of the kale. The bacteria will work as communities to digest things together. So I'll chip one bit off and you'll take another bit off and another microbe will do another bit. Microbes can actually grow on the mucus that we produce to line our gut. They can live on, various different foods that we ingest. And so the microbes are feeding off us and they're feeding off our food.
Right.
The microbes on the food are essentially just passing through. It appears very significantly. Now, a colleague of mine here in UCC, Professor John Cryan, is probably the world expert on this. But I work with him and I know him, so I'm familiar with his work, although he is the expert. And he does a lot of work in largely in animals, but now as well in humans. And as I said already, a lot of our nerve endings are in the gut, and we've got this very big connection between the gut and the brain. And what John has shown is that if you take an animal like a mouse or a rat, and you grow it in an environment where it has no bacteria, so it never ever encounters a microbe. They're called germ-free animals. So they will grow, you can feed them and they will grow into full-size animals, but their brains never develop properly. They never learn how to learn properly. They suffer from anxiety and stress at an extraordinary level. So we know that microbes play a role in how our brains develop and in how they respond to stresses and things around us. But that's, of course, very extreme. That's lots of microbes or no microbes at all. What John and his colleagues have been working on now is trying to find which microbes in the gut actually are the most important ones in these communications. And they've identified some probiotics, which they can administer people with very mild symptoms like anxiety, not full-blown depression, but anxiety. And you do see an improvement in symptoms of anxiety and things, and in cognition, in your ability to memorize things and even do very simple tests can improve in the group that gets the probiotic, but not in the group that gets the placebo. And so that's the kind of evidence we need to show. So the short answer is yes, the microbiome plays a very significant role in our mood. And the longer answer is very complicated about which areas of mood and which areas of memory and things that might play a role.
You eating yourself sourdough?
I only eat sourdough bread. And I make my own kefir and my own kombucha, and I eat yogurt and cheese and fermented meats.
So you've got the whole diversity of the foods which nourishing your guts.
I just love them.
Yeah.
And I do feel better when I have them. So that's good enough for me. I can put the science part of my brain to one side and say, as a human being, I feel better eating these, and so I'm going to keep doing it. Well, I believe my own experience. I believe and trust my own reaction to things. And so I know when I eat sourdough bread and drink kombucha and eat fermented foods that I feel better. So I do it. And that's real. And no scientist could persuade me you're wrong, because I said, well, how could I be wrong? I feel better. So I do it, and then I feel better again. So there's no wrong here. I'm not trying to say I've scientifically proven this is correct. I'm just saying this is my experience and I trust it and believe it. So I think you should always trust and believe your own experience. There are many things in your life that give you pleasure or keep you healthy that have not been scientifically proven to do that, but you know they do it, and so you keep doing it. And you know, I see no object. I'm a microbiologist. I make kombucha and I drink it because I believe it does me good, but I know there's no scientific proof for that, or at least scientifically it has never been proven, but I believe it, and so I do it. And I don't see any contradiction there, because I'm not going out telling people if you eat kombucha you will feel better. I'm just saying when I do it I feel better.
Right.
That's it. I'm not.
Yeah.
If I've scientifically proved it in some big trial with thousands of people, then I'd be going out to people saying you should, because it definitely makes you better. I can't say that, but I can definitely say to anyone who wants to hear it, I do it, it makes me feel better, and I believe it.